Let's talk about AI. So many people knows NVIDIA, for the GPU that we have, for the infrastructure, but not many realize that NVIDIA actually develops a lot of software. So we are taking industry by industry, understanding where are the workloads that AI can really accelerate, and we invest in developing those libraries to support the developers or the researchers of the future. So you will see a list of many libraries that we are developing to really support those industries, from physics, understanding the law of physics and how they influences the materials that we are using, through data analytics, through quantum chemistry, through understanding medical imaging, genomics, many areas, and we influence almost every industry that is there. One of the key things that I think really transferred artificial intelligence to what it is today is the first time that a computer understood the human language. This is actually when ChatGPT came to the world. And really, this is the first time we understood the semantic of words. And the semantic of words is not limited only to spoken language. This semantic of words or language can be a finance language, can be a cyber language, can be a chemicals language or protein language, and can really understand many things. But the idea behind this transformation that happened is the ability to move from one model to the other, from text to speech, from image to video. This is what we call multimodality. So some of those movements we already know, like from text to text, it's summarization. From different languages, it might be translation. From video to text is sorry, I forgot the word about what we see below the subtitles, exactly. So we actually are, some of those things that we are already seeing and using, but AI is now transforming that. So when we started, actually, things were easier, just understanding images, what we call perception AI. This is actually where everything starts, and really understanding an image and becoming to superhuman capabilities. We then moved to generative AI. This is where the age where ChatGPT entered and other large language models came in. And this is actually where we started to generate content. Now we are moving toward what we call agentic AI, where we will see more agents supporting our day-to-day work and really walking us through some of the challenges we are all experiencing. And in parallel to that, we're also seeing movement to physical AI, which are robots. So there isn't any questions that robots will be here, right? Supporting us. In 10 years from now, probably robots will support us at our house. Robots will be participating in our driving in our car, in surgery, in hospitals. So this is actually the transformation that AI is doing. And we are now focused on agents, developing agents to support, finance, healthcare, our day-to-day. And I think, again, 10 years from now, we'll have someone on our shoulder here that really knows us very well and is able to support us and support what we are doing and help us achieve our goals faster. So the AI, actually, the computing architecture has changed, when AI entered the game. You don't see here, CPU or Windows, okay? It's a different architecture of computing. And it starts with energy, of course, because energy is what drives those new methods or new concepts that are called GPU supercomputers. We didn't need so much computation for running, a web browser or a Word or an Excel, but to run a ChatGPT or Cloud or Gemini, we need, GPU supercomputers that are able to understand context and really support our day-to-day. Above that, there is actually AI infrastructure that started by supporting different generic models that understand vision, understand spatial, models that are able to move from one model to another model. This is like the basic language that we are seeing that is coming out of giant companies that really develop those models. The second stage, after using those models, and every one of us uses them, whether we go through a specific large language model, are applications. And unlike the applications of the past, which are tools, actually, tools that we were using, we all use Word, we all use PowerPoint, we all use web browser, but the new AI applications are actually the brain that is using these tools. So if I take, for example, a robotaxi, in the robotaxi, there is an engine, an AI engine, that is called chauffeur, and the tool is the car that it drives, okay? So, and if we take a look at digital biology or an AI coder, so there is an AI engine called Cursor that, by the way, NVIDIA is using. Each one of our developers uses Cursor. The tool he's using is called VS Code. So the thinking part that the application is actually developing, this is the toughest thing to do. Thinking and building this AI engine applications. So this market is evolving. So if I look at the tools market, this is like a $1 trillion market of IT tools, databases, applications that we are using up until now. The industries that AI is approaching is $100 trillion to really build those AI applications that are really changing our day-to-day. Think about it, how complicated it is, to drive a car that uses autonomous capabilities. For example, it needs to understand the context, the questions I'm asking to do, it needs to recognize the environment, it needs to take a decision, and this process that is done is heavy computation requirements. So, and this influences, as I said, digital biology, science, robotics, manufacturing, robotaxis, and actually every application. So, eventually, to be able to really support this amazing growth, we see a new area that is called AI factories. So, unlike factories of the future, of the past, where we needed to have, electricity inside the factory, have turbines and, water inside the factory, have turbines and create electricity. Today, we actually have data. We have, chunks and chunks of GPUs and compute AI infrastructure, and we actually generate intelligence. Those AI factories are machines that are using energy to create numbers. Those numbers are tokens. Token can be an English word. Token can be an image, can be a 3D image, it can be a protein, it can be a chemical, it can be a brainwave, it can be any of the languages that we can teach this machine to understand. So those AI factories are actually the factories of the future. Okay? They require enormous amounts of energy, and they use GPU supercomputers, and we're seeing that growing in every country globally, where every country is using its natural resources to build AI factories that will support the growth of the countries. So there are actually, three scaling laws that really influence the level of intelligence that AI can produce. Okay, the basic one is called pre-training scaling, similar to preschool. Okay. When we go to preschool, we learn the basic language, we learn vocabulary, we learn how to learn. This is like memorization process of artificial intelligence. This is actually what started. When we took the internet, we taught it to some large language models, and actually we now understand and we learn how to give you answers to questions that you have that are based on the data that I memorized. The second scaling law is called post-training, and this is actually where we add skills, where we use like a doctor that can really analyze the response and make sure that it's more accurate. When we use a specific skills and we actually improve the level of intelligence that this model can produce us. The third one is called reasoning or long thinking. This is actually where we are taking complicated problems. You know that part of your day when someone speaks to you and you don't answer, you just stop and you are thinking. Your brain is breaking a complicated problem to many small problems and try to actually, build an answer. So the computer is doing the same. It's reasoning the answers. and is breaking a complicated problem to smaller, different problems. Maybe an agent will solve each one of those problems, but eventually, this requires even much more computation power. So the more we go up the scaling laws, the more computation we will need to process and give a more intelligent answer to the question we are trying to ask. So this is actually becoming like a virtual cycle. So think about it. A year ago, something really meaningful happened because up until a year or year and a half ago, people were saying, AI is here, I'm not sure I can trust it, I'm not sure I can use it. But now we know for sure that the intelligence level is very high, and people are using more and more AI. How many people here are paying for using AI? Exactly, so you see the number. So you trust the model to be intelligent enough for you, so you're willing to pay money, okay? So the more it's an intelligent, you get intelligent answer, the more you adopt it. The more you adopt it, you actually are using more compute power to really generate a request for more compute, because think about it. Every industry, every question you want to ask, you want to respond quite fast. And probably you see that today, in rush hours, the models respond slow. So it requires more and more compute to be able to give you fast answers and more accurate answers. So the more you adopt it, actually, the companies are making more profits. Okay, so if they make more profits, they want to invest more and build more compute. We go up the level of the scaling laws I just explained, of really doing a more advanced model that require more compute. So this is and eventually it creates much more intelligent model. And again, the more intelligent, the more we use it. So this is like the virtual cycle that shows that AI is here to stay, to solve complicated problems. It will influence everything that we are doing in each industry. So, and Israel, as a country, as our CEO, Jensen Huang, when he's visited Israel, said, we are home to world-leading AI researchers. We have 1,200 startups in our startup program in Israel. We have huge collaboration with academia and researchers in Israel in many industries. Cyber, for sure, is one of the drivers of Israel, but unlike, cybersecurity, when you take a 17-year-old kid, you give him access to a laptop, and he does smart things, the same 17-year-old kid needs access to supercomputer capabilities to really build what he can do with AI, as I just explained. So I wish we will have more AI infrastructure to support those massive brains of the Israeli people. And with that, thank you very much.